All right, so what we're going to be doing today is integration with partial fractions. And what we're going to be focusing on to start and throughout is when it's applicable to use partial fractions and actually how to go through them. All right, so partial fractions are used to integrate rational functions like f of x when f of x equals p of x over q of x, assuming that both p of x and q of x are polynomials. Now, in order for this to actually work, the degree of p of x, the absolute degree of p of x must be less than q of x. For example, x cubed plus 7x over x to the fourth minus 1. Since q of x has a greater degree on bottom than p of x on the top, if this was f of x, we could integrate by partial fractions. All right, so let's start with a simple example. When you see a partial fraction problem, it could be written as d of x over x squared minus 6x plus 8. Now this is equivalent to saying the integral of 1 over x squared minus 6x plus 8 dx. Now the first thing we want to do is we want to factor the bottom out into its simplest form. So what we are left with is 1 over x minus 2 and x minus 4 dx. Next, we are going to decompose this down into 1 over x minus 2 times x minus 4 is equivalent to saying a over x minus 2 plus b over x minus 4. Now, the next step is going to be to cancel the denominators across all sides. So I'm going to rewrite it real quick. 1 over x minus 2, x minus 4 is equal to a over x minus 2 plus b over x minus 4. Now, in order to cancel the denominator on all sides and all terms, you have to multiply them by the entire bottom. So this entire piece right here will be multiplied by the bottom again. So we are left with x minus 2, x minus 4 over x minus 2, x minus 4, which cancels out down to 1. Then on this side, we have a times x minus 2 times x minus 4 over x minus 2 plus b times x minus 2 by x minus 4 over x minus 4. Now for these, the x minus 2's cancel out for A and the x minus 4's cancel out on B. So now we have 1 equals A times x minus 4 plus B times x minus 2. Now we have to sub in values for x to find A and B. All right, so to cancel out this 4 here, we're going to set x equal to 4 to start. So now we simply sub x in, and we are left with 1 equals A times 0 plus B times 2. So the A times 0 obviously drops out. We have 1 equals B times 2. So we divide by 2, and we get 1/2 equals B. Then we plug in the x minus 2, or x equals 2, in order to cancel the B, so we can find A. So with x minus 2, we now have 1 equals A times 2 minus 4 plus B times 0. So that's 1 equals A by negative 2. So A equals negative 1/2. And now we plug both our B value and our A value back in to our decomposed form here and here. So we have 1 over x minus 2 times x minus 4 equals negative 1/2 over x minus 2 plus 1/2 over x minus 4. Now we can integrate, once again, both sides of the equation. And when we integrate this side, we can integrate each part separately. Now, the 1/2 and the negative 1/2 out front, since they're simply being multiplied in, we can rewrite this as negative 1/2 of the integral of 1 over x minus 2 dx plus 1/2 of the integral of 1 over x minus 4 dx. Then when we integrate this, what we end up with is negative 1/2 ln absolute value of x minus 2 plus 1/2 ln absolute value of x minus 4 plus c. Do not forget the constant of integration. Then this can also be simplified down to 1/2 ln x minus 4 minus 1/2 ln x minus 2 plus c. Now, since they have the same leading coefficient on each side, we can use our rule of powers to say 1/2 ln of x minus 4 over x minus 2. And this is how, plus c, and this is how it would appear on a multiple choice on the AP exam. Now we're going to do something a little more complex, but we're still going to follow the same general rules. So we're going to start with the integral of x squared plus 2 over x minus 1 times 2x minus 8 times x plus 2 dx. And the only difference between this and what we had last time is we do not have a 1 on top, we actually have a function. So we're going to break it out like we did last time. So we have our x squared plus 2 over our x minus 1, 2x minus 8, and x plus 2 equals our a over x minus 1 plus b over 2x minus 8. And since we have a third term right here, we're going to go plus c over x plus 2. And then we multiply everything by what's on the bottom. And what that breaks down into is x squared plus 2 equals a times 2x minus 8 times x plus 2 plus b by x minus 1 by the x plus 2 plus c by x minus 1 by 2x minus 8. Now at this point, you may be tempted to combine these sections here, here, and here. Don't. Just leave them separated like that. It's going to make it easier when we plug in values for x to solve for a, b, and c. So I'm going to rewrite that. So x squared plus 2 equals a by 2x minus 8 by x plus 2 plus b by x minus 1 by x plus 2 plus c by x minus 1 by 2x minus 8. Now we're going to plug in our x values so that we can clear away 2 of the 3 terms up here. So I'm going to start with x equals 1, because this will cause this term to go to 0 as well as this one, which will effectively eliminate our b and c from our equation for the moment. But you have to remember that when you plug x in, you also have to plug it in over here. So we have 1 squared plus 2 equals a by 2 minus 8 by 3. So what this works out to is 3 equals a by negative 18. Now, if you're confused on how I got that, 2 minus 8 gives us the negative 6 times 3 gives us the negative 18. And now we divide the negative 18 over, and we end up with negative 1/6 equals a. So now we're going to plug in another x value in order to eliminate another set of terms, and this time we're going to use x equals negative 2. to effectively turn this to 0 and this to 0, so we are left with only c. So now we have, and then again, do not forget to plug this back in over here. So we have -2 squared plus 2 equals c, sorry about that, b, because we're actually going to eliminate this term and this term, not this one and this one. So what the -2 effectively does is it turns this 2 here into a -4. No. Crap. Please stop, Arthur. No. Okay.
Yeah.
All right, so what I'm actually going to do is I'm just going to write out the entire thing without skipping. And so hopefully this time we won't get lost. -2 squared plus 2 equals a by -4 minus 8 by 0 plus b by -2 minus 1 by 0 plus c by -2 minus 1 by -4 minus 8. So now, out front, we get this -2 squared, which goes to a +4 plus 2, which gives us 6, which equals, so the a is going to drop away, the b is going to drop away, we're left with c by -3 by -12. Well, this gives us 6 equals c by a positive, because we have the double negatives, 36, which then gives us c equals +1/6. All right, now we're going to go to a new page. That one's getting filled up. And this time, we're going to set x equal to 4. So now we have 4 squared plus 2 equals a times 8 minus 8 by 4 plus 2 plus b by 3 times 6 plus c by 3 by 8 minus 8. Now, since the 8 minus 8 on either side go to 0, our a disappears and our c disappears. So we're left with 18 equals b. That's a 6. You can't see it. By 18. So effectively, b equals 1. So now we take our a, b, and c values and plug them back into the original, or back into our decomposed piece. So now we have x squared plus 2 over x minus 1, 2x minus 8 by x plus 2 equals -1/6 over x minus 1 plus 1 over 2x minus 8 plus 1/6 over x plus 2. So now we can integrate both sides with respect to x. It's effectively, and once again, we can bring out this term and this term to the front of each piece respectively. So we have negative 1/6 integral of 1 over x minus 1 dx plus the integral of 1 over 2x minus 8 dx plus 1/6 the integral of 1 over x plus 2 dx. So when we integrate this, we get negative 1/6 ln absolute value of x minus 1 plus, now in this term we have to consider the chain rule that would be used when differentiating, so we have to take care of the 2 that would come out of that. So we divide by 1/2, so 1/2 of ln absolute value 2x minus 8 plus 1/6 ln absolute value of x plus 2 plus c. Sorry about that. And that effectively is our answer. All right, so that's basics of integration by partial fractions, a simple example and one that's slightly more complex. I hope you learned something.